Number 25, we're starting with 900. And we're supposed to add 36. Okay, guys, stop talking. All right, so how do I find the percent change? That's going to go in the third column. What's the little formula we use for percent change?
Change over original.
Change divided by original. Sorry, girls. Just want to move quickly. Change divided by original. So the plus 36, that is the change. And the 900 is the original. We're going to change this to a decimal and we're going to round. Actually, I don't think we're going to have to round on this one.
Is it 4% over that?
Yes. So it's 0.04. So 4% increase, going up by a little bit. Okay, and then how do we find the new
Just
value?
936.
Yeah, it's just 900 plus 36. $36 is 4% of 900, and then to increase it, you just add them together. All right. Number 27. So on this one, we don't know the original, so this is kind of like, I think everybody's here.
Like pictures.
Mr. Jordan, you didn't change that target.
I fixed it.
No, they're taking pictures for your book. Like a people's
Oh, yeah. The retakes.
Okay.
Wait, when's retakes?
I don't know.
Retake.
Oh, yeah. It's in the notebook. I have a you.
All right, 27 is one of the harder ones. If the value is going to go down 35, and that's a 20% decrease, how do I find what this must have been?
I really don't know.
You don't have to share it in that case.
Wait, you know we're done. You do the, okay, so you do the 35 times and equals 20%.
Close.
Divide?
Okay,
Which one is it?
here's what it means. Listen, 20% of this number is 35. Remember, to find what we add or subtract by, we multiply by the percent to get this number, right? And then we add or subtract it. So 20%, of this number is 35.
Oh, so it's actually
You said it backwards. You said 35 n is equals 20%. Okay, so yeah, you just divide by 0.20.
175.
So yeah, I'm using the tricks. What? I'm using the 20% of this number, just like we do on those written problems. You guys are pretty good at the written problems, so if you can just interpret it into one of those, you should be good.
175.
So it's 175, and then it's going to go down 35.
So 140.
So the new is 140.
$29 is so weird. What the heck? What is
The
it?
heck?
I've never seen
Okay.
a lacrosse match.
A lacrosse match?
How many of the 400 in attendance were watching their first game
Oh,
of
you know number
lacrosse?
7? She plays lacrosse.
I can see that. Of course they have lacrosse.
Jack plays
Yeah.
lacrosse.
You guys know what lacrosse is?
Lacrosse is actually really
I
fun.
like watching
Hall and Hall and like Hall and Hall and Cash and Hall all have.
What, Chase?
Yeah, Hall and Hall and Cash and Hall both have.
It's terrifying though because they run.
Oh, you do know what it is,
football
okay.
with sticks.
Thought you had a comment on lacrosse. Okay. 28, I probably could skip this one, but 5 out of 40 questions were missed. So how many did they get right? It says 5 out of 40 questions were missed. So how many did they get right? 35 out of 40. And you have to change that to a percent. You guys know how to change fraction to a percent? You divide. Okay, 29 is the lacrosse one. 30% of those in attendance. So we already have some keywords. 30% is going to turn into what?
0.30 or
0.3, 0.30. 30% of, anytime you see of, a little light should go off in your head. What's of mean?
Times.
Okay, it said of those in attendance, and I don't know what that is yet, but maybe if we keep reading, it will tell us. 30% of those in attendance have never seen a lacrosse match. How many of the 400 in attendance, so where does 400 go?
Equals.
No,
Attendance.
it's the attendance. So 30% of those 400 people have never seen a lacrosse match. That's basically what they're saying. If you like boil it down to the basics. And then they say, how many are watching it for the first time? So basically, 30% of 400 have never seen it, so this will be their first time. And how many is that? 120. And then it says, make sure you read everything. How many have seen it before? There's 2 ways we could find that out.
400 minus 120.
Right, we can do 400 minus 120. Does anybody know the other way?
120 plus
Add.
10 equals 400.
No.
I think we both said add.
I mean, that is one way to do it.
Okay, well, if 30% have never seen it, that means 70% have. So you could also do 70% times 400. And that would give
But
you,
subtraction's way easier.
well, if you're using your calculator, I'd say there's fewer buttons with 0.7 times 400. Maybe easier to understand, but they're both kind of easy. All right. I probably okay. How much help will we get here?
I say when we're done, we should just have like half time.
I'd say you should do the odds when we're done.
No, it's not
Ew, 30 through 32 is weird.
That's what you said about 29. You feel all word problems are weird. Okay.
Where do you
I
get these
do.
comebacks?
Huh?
I said, where do you get these comebacks?
In my head,
Oh, is that the slip back from last
in my brain, in my mind.
I would wash my hair and I would sleep
Not
on
her
bed.
itchy or
And
head.
it was, I'm trying to put it
Top
back in.
10 rows.
Okay, on 30, the Zimmermans know that they usually average 55 miles an hour. 55 miles an hour is going to be the what?
Right?
Right. So remember our little formula?
Rate times time equals distance.
Rate times time equals distance. So we're going to have to plug that in later. They're driving 715 miles to visit grandparents. They leave at 6 a.m. Okay, so that's like all the foundational information. What time should the Zimmermans tell their grandparents to expect them to arrive? So in other words, we need to figure out how long it's going to take them to drive there. We know, okay, 55 miles an hour. Where's 55 go? 55 miles an hour?
Wait.
Where does 715 miles go? So we're missing the time. And how are we going to find the time?
You divide.
Divide by 55. Yeah, that's fine. Just remember this is even. $13, what does that mean in this problem? 13 hours. That is a miserable drive.
Just go see your grandparents.
They get there
They
at
like
7
live in
p.m.
Florida or something.
7 p.m.
Okay, yeah, so they started at 6 a.m.
7 here.
Yeah, 6 a.m. to 6 p.m. is 12 hours. You guys knew that, right? In my head, I'm going around the clock in 12 hours. So one more hour, yeah, would be 7 p.m. is final answer. Okay, 31. If they arrive at 9 p.m. Okay, well, if they arrived at 9 p.m., then they must not have been going 55 miles an hour. So,
They stopped.
well,
They have kids, they stop.
they're probably factoring in the fact that they're taking stops as part of their average speed.
Or they got pulled over, maybe that's.
They got pulled over for speeding going 55.
You didn't get 55 miles an hour.
They were doing 55 and a 45.
School zone, yeah. If they arrive at 9 p.m., what was their speed? So, if they arrived at 9 p.m. and they started at 6 a.m.,
15 hours?
yeah, so 6 a.m. is 6 in the morning.
That's horrible.
We're at 8:15. So if you go around 12 hours, that's 6 p.m. 3 more hours, it's 9 p.m. So that's 15 hours of driving. So that would be their time.
So I'll be dead.
I would be jumping out of there at like 3 hours.
But we don't know their rate. So I'm still using this formula. Distance, I'm still 7:15. Well, I switched the T and the R, but the time times the rate should equal the distance. So what to do? Divide again.
47.6.
You guys know what?
47.
Do you guys know what 0.6 repeating is?
3/4, 2/3.
7, because it can run it.
It's 2/3, yes.
2/3. I was right.
I'm waiting for you guys.
All right. But if it was 0.6 repeating, it would round up to 0.7, because you have a bunch of sixes. So this 6 would round that up to a 0.7. All right, okay. 32.
7.
I have no legs.
37.
Are you sure you went to 6?
37.
Oh, that's how far we're going? Oh, we're jumping. Oh, 32, yeah. Okay, I'll just help you guys set this one up. On the way home, the Zimmermans, so on the way home, what's the distance going to be on the way home? Still 7:15. As far to get there as it is to get back. They left at 10 a.m. They drove an average of 50 miles an hour. And they stopped at a hotel for the night at 6 p.m. So if they went from 10 a.m. Okay, it's almost a couple hours will be 10 a.m. Once you get to noon, it's 12 p.m. and then it goes to 6 p.m. How many hours is it from 10 to 6? 8, yeah. 2 hours to get there, 6 hours to go over. So that's an 8-hour drive. So they didn't make it all in one trip. This is how I would have to do it. I would fall asleep. Anyways, they drove for 8 hours, going 50 miles an hour. So how far did they drive in the first day?
50 miles.
They drove for 8 hours, going 50 miles an
8
hour.
hours your time.
Right.
55 is your rate.
Rate times time equals 400 miles. Okay, that's not the answer. We just need to know that. You guys know what miles per hour means, right? That your speed is based on how far you can get in 1 hour. So if you're going 50 miles an hour for 8 hours, you've gone 8 50s, 8 times 50. Anyways, so they've gone 400 miles. I haven't got to the question yet, but they're probably gonna have to figure out like something about
It's
how much distance is left. That's what I'm trying to say. 7:15 total, right? So how far do they have left to go?
350.
350. Okay, that's not the answer either, we just need to know that. Oh, how many miles do they need to travel to get home? Never mind, sorry, that was the answer. I thought they were gonna ask how fast they're gonna go or something. Never mind. I just assumed, because I didn't read the whole question. 37, write an equation and solve. A traveler priced an airplane ticket at $650. He was later able to get it for $400. How would he get the price drop? I don't know. What percent did he save? Okay. So what was the percent drop? So they don't always say it, but this is a percent change problem. Like what percent did he save? What percent was the change? That's kind of the same thing. But they don't always say what was the percent change. But if we're talking about the change and we're looking for a percent, that's what it is. So what's the little percent change formula we used over and over?
Difference over change.
Change, which is like the difference, yes, divided by original.
250 divided by 60.
Yeah, the change, you subtract these two. It's going down by 250. The original is 650. And you divide. The end. Well, and you change it to a percent as well.
42, wait.
38. Or
Yeah, point
38.
38.4, because you.
Okay. What's the
You're
percent?
supposed to do the change over the
38.4%.
So you do the change over.
Actually, let's go one more decimal place because we need to round this one.
6.
Okay, so this would be 38.5. Yeah, always, if you're rounding a number off, you always need to make sure you look at the next digit. You can't just cut it off. Let me look at 38. 38. The retail price of a suit was $719, so the normal price was $719. It was reduced 33%, and then later reduced an additional 67%. Wow, that's a lot of dropping. What was the price after both reductions? What was the total? Oof, that was a tough one. Yeah, fine. All right. So we got to drop it by 33%. So we want a 33% reduction on this. So how do we make this number go down by 33%?
Multiply by 0.33.
Right. The first step is figure out what is 33% of this number.
237.27.
Okay, is that what it's going to drop to?
No.
No,
We
that's
just dropped it in
that's how much it's going to drop by. This is the price reduction. But we would need to subtract that to get the new price.
$481.73.
Okay, then they said after that it dropped by an additional 67%.
Just do 100% already.
No, it's not 100%. If it's not 100%, it's not 67% of the original. It's 67% of
And
this.
then times 0.67 is 322.7591.
Okay, we're talking about money, so where should we probably round it?
The hundreds.
Right.
So
Because
76.
we go to 1 cent place on money, right? So we 0.76.
Yes.
Okay, so again, that's not what the price drops to, that's what the price drops by. That's how much the price is gonna go down.
Alright.
That's negative 158.97.
Well, it's not negative.
Or, I mean, sorry, negative.
If you
100
subtract, yeah, go ahead.
Yeah, 158.97. The next digit is 0, so.
Okay, yeah. So if you subtract backwards, you get the same value, but it's negative.
Yeah, that's
in
what
this
I did, because I
case.
hate rewriting.
Yeah. All right. And I think there's one more question. So what was the effective percent reduction from the original? So we went from 719 originally, and now it's down to like $159. So what percent overall did it drop?
100%.
It did not drop 100%. 100% drop would be $0.
Right. So
The reason it's not 100% is because we didn't do 67% of this.
Yeah.
We did 67% of that.
So how would you say that?
Well,
How would you say the total price drop?
how do we figure out the price drop? The percent drop is a percent change question. So how do we do percent change? Change divided by the original. So we need the change between these two. So subtract these two and then divide that by the original.
It's 560.03.
Divided by 0.3?
0, yeah, 0.03.
Oh, 0.0, okay.
It is 0.7789.
So probably rounds to, okay, 0.7789. So that's about 77.9%.
9%.
Yeah, that's a lot of dropping. Time to buy, girls. It's on sale. Okay, were there 3 questions on that? What was the price after both reductions? They asked 3 questions, but then they only list 2. So the 3 answers were this one, and this one, and this one. That was a doozy, wasn't it?
Yeah, sure.
Oh, it's too
A bit much. The ones on the test will be more like 1-step problems, not 2-step, 3 steps.
4 steps.
Okay, where are we at? 39? We're almost done on the home stretch. Oh, I should give you guys one to do, shouldn't I? Oh, I didn't give us a distance problem that was like with the arrows.
Oh, please do not.
Please, no.
So we'll need to do one of those.
Oh, wait, that one? Mr. Jordan.
I still didn't get it.
Mr. Jordan, please
After I did it like 4 times. What?
Please don't.
Also, are you on number 2?
This one's for you, Joe. All right. Actually, this one's not. 39. Ron earns a 15% commission. Do you guys remember what commission meant?
You sell something, you get money when it sells.
If you're a salesperson for big ticket items, you get a percent of what you sell.
Commission.
Sell.
A commission.
Yeah, and 15% means whatever they sell, they get to keep 15% of that for themselves. It's a large commission. 15%. Ron earns 15% commission on his sales in addition to his $1,500 monthly salary. Determine his monthly sales goal if he budgets $3,750 as his monthly income.
37,000 or 3,700?
$3,750 as his monthly income. Okay, so he's gonna get $1,500 no matter what, right? You just kind of sit there for existing. Plus, he's gonna get 15% of what he sells. So how would I write that? He's gonna get 15% of what he sells.
15% increase.
Right. He's gonna get 15% of his sales. And altogether, he wants to make 3,750. So he's gonna get $1,500 just for having the job. Then he's gonna get 15% of what he sells. S might not be the best letter to use because it looks like a 5.
Just use
But
an N, please.
kind of reminds you what it stands for, though.
Yeah.
Or you could maybe use a lowercase s so it looks less like a 5.
Okay, better.
Anyway, and solve.
I don't know.
Well, don't you just like
Yes,
subtract 1500?
Yep, subtract, divide, just do the basic algebra steps. Yeah, let's add on 42. How much are we doing on time? I think we can do this in less than 5 minutes. Well, we did some distance problems, but I want the kind with the arrows. That's the problem. Okay. So I'm going to do 43. Jorge jogged down the... So remember on these problems where there's two distances, we always started with the arrows, right? And then we labeled the rate and the time, and then we set up an equation. Yeah, added on 42, 43. 43, Jorge jogged the trail to the waterfall at 120 yards a minute. And he walked back at 80 yards a minute. If the entire trip took 2 hours, oh, it's a tough one. How long is the trail in yards to the nearest tenth of a mile? Oh, gosh. Okay, so what's the picture? He jogged to the waterfall and then he walked back. What would that picture look like?
He's going on the
Going on the edge.
Okay, so what's going to be true about these two distances? They're the same. Going there is one distance, coming back is the same distance. So it's going to be whatever this distance is equals this distance. So it's just going to be that equals that. Okay, they both are going to get a rate and a time. This one has a trick that we haven't quite seen yet, so kind of regretting choosing this one, but it's okay. I'm going to do it anyway. Okay, it says he jogs 120 yards per minute. That would be his what? Rate. It's not a miles per hour, but that's still a rate. So that's his R. And then it says he walks back at 80 yards per minute. So that's his R2. Okay, now what's the time? This is where the concerning part comes in, but we'll try. We'll look at it. It doesn't tell you how long he ran or walked. It just says the entire trip took 2 hours. Yeah, but it's not the time for this and this. It's the time for like the total. So that makes it a little trickier.
120t plus 80t equals...
Yeah. Okay, so here's what I'm going to do. We haven't quite seen this before. I'm just going to kind of randomly choose one of these to be called T. So I'll say the time it took him to jog there is called T. So how much time remains for him to walk back? Let's say he jogged there in like 30 minutes. How much time would he have to walk back if it's a 2 hour round trip? Hour and a half. So how did you get that? You did 2 hours minus 30 minutes. Okay, or if this was 40 minutes, you do 2 hours minus 40 minutes is like an hour and 20 minutes. So whatever this time is going to be 2 minus this. So this time is 2 minus t. The one on the test, I'm not going to put that trick on there. It's one of the other ones that we've used. Maybe like this guy was going 30 faster, so you have to do like r plus 30, that kind of thing. This one's a little trickier. All right. What's the relationship between these two distances? They're equal. So that means 120t equals
And do you do distributive property?
yeah, just do normal stuff after that. Okay. The setting it up, that's the hard part. Whoops. Okay, now what do I do? Add 80t. So we want all our t's to one side. So that goes away. 200t
Equals 160. 5 and 60.
is that 4/5?
Yeah.
Yeah, it's 4/5.
Well, this would be like 4/5 of an hour. You guys know what 4/5 of an hour is?
55. Is it 40? 55 minutes.
You do 4/5 times 60 minutes. Is like 48 minutes.
48.
We don't really need to. We don't actually have to know that for this though, because that's not the question.
I said 50.
You were close. That'd be 5/6 of an hour. Okay. The actual question though, this is also a little different on this one, is how far was it to the waterfall? So, how do we find the distance from here to here?
Multiply 120 by 4.
Right, you do rate times time. So 120 times 4/5. Yeah, t is going to be replaced with 4/5.
96.
96. Well, we're doing yards per minute, right? So it's 96 yards. No, that's too short. Forgot what it said. 120 yards a minute. Oh, gosh. It's 4/5 of an hour. Darn it. Okay, the rate is in yards per minute, so we actually would need the minutes on this. Sorry about that. So we actually would need the 48. Yeah. Okay, so it comes out as much larger, 5,760 yards. That was a toughie. Okay, I want you guys, 42 is not going to be that bad. 42, I want you guys to try and set it up on your own, see if you can get it all the way. 42 is more normal, like the homework we did. Start with the arrows, plug in the rate and the time. The more you do on the test, the more credit I will give you. It's not going to be an all or nothing unless you just like leave it blank or don't do anything.
So what if we get the answer wrong? Just do it credit?
It depends on how much, it depends on how much you get right. Like the more you get right, the more credit. Kind of like an essay question. But it's a word problem. Guys, try 42. Try it.
Wait, if this says drives the 120 miles Newton at 46. Lower it up.
Try it on your own first. Try to make a picture. Like walnuts that fall on the roofs. Oops. Oopsie. Alright, you gotta get that part?
Wait,
No.
They're driving towards each other. Where does 120 miles go?
okay, I think I figured it out. I don't.
120 miles is how far apart the cities are from Greenup to Newton. So it goes all the way across. And what else does it tell us? Julie, how's she only going 46? Anyway, Julie's going 46 and the other girl's going 34. And did they start at the same time, I'm guessing?
Doesn't.
They leave at the same time. So that means we can call both of their times t. We don't know what they are, but we do know that they're the same.
It's the same number.
Yeah.
Yeah, because they start at the same time, and when they meet up, obviously that'll be at the same time. So, what is the equation? How are these distances related to each other?
Well, I put
46
46.
feet plus 34 t equals 120.
Right.
Oh, shoot.
Okay. Julie's distance plus the other girl's distance, because they're going to travel this whole distance, should equal the 120 miles. So 46t plus 34t equals 120. Okay. There's no trick question on this one. It's just how long is it till they meet. So when you solve that for t, that would be the answer.